Once you have all your parts designed, you can start creating your assembly. Here's a little view of what the final assembly should look like. And to get started with an assembly, basically you go File, New, and we're going to go a standard.iam or inventor assembly, and then go Create. And basically you're going to need to start placing the items in the assembly and then constrain them so that they're in the right spot and they move appropriately if they are movable parts. And so I'm going to just start with a gearbox plate, and there are two of these. Notice if I click once, it allows me to keep clicking to add parts, and I'm going to click another one. And then to get out, I can either right click and hit OK, or I can just hit Escape. And I'm just going to place some others. You can control click when you add parts, so you can add multiple parts. So, maybe I want to add both gears at the same time and the bearing. And so hit OK, and I click, and then I can hit Escape. There are multiple bearings in here. There's actually 4, so I can just go Control C, Control B. And let me place just a couple more parts in. I'm going to place the axle, and I'll do the plate spacer. You can place all the pieces in at the very beginning. Sometimes it gets a little cluttered, and so I don't necessarily do that. Before doing any constraints, and again, the constraints are what force the pieces to fit in a certain location so that they don't just move around like they are now. I ground at least one piece, and so I'm just going to take this gearbox plate, right click on it, and ground it so it doesn't move anymore. You can kind of see the thumbtack there. Then I need to constrain. You can rotate a part using free rotate, and I use that a lot. If I notice, I hover, the shortcut is G, and I click here, and I can hit G and then left click and just rotate this part instead of the entire assembly. Now if I hit Escape and drag the part, it may not necessarily stay there if there are other constraints added. Now I haven't added any constraints, so it doesn't really matter at this point, so it doesn't kind of snap back to a different orientation. But it would if it had constraints that forced it to be in that. And I'll show you this in a minute, and maybe it'll make a little bit more sense. So the reason why I rotated it the other way is you can see these counter bores. They are for these little spacers that go in there, and so they need to face inward. And so I kind of rotated it around so the counter bores face inward. Now I'm going to use a couple of constraints to make this aligned with this. And so to do this, I'm going to hit C for constrain. You can also hit constrain here. It brings up a window. We're mainly going to use just a few types of constraints in this assignment. We're going to use the flush constraint, where two faces are flush with one another. Mate constraint, where we have two planes facing one another or mated, or you can mate two axes together as well. We'll be doing that. So let me start with a flush. I know that the top of this face needs to be flush with the top here. And when I do that, I can hit apply, and it makes those flush. I also know that this face here needs to be flush with this face here. And I hit apply. So now when I move this piece, it's constrained so that these two faces here are flush and these two faces here are flush. I can still slide it back and forth, but those constraints exist. And if I expand these two plates, I'm going to notice the constraints were between gearbox plate, the first one I placed down, and the second one. And if I expand each of these, you can see these constraints. Notice the first constraint was this, and they called it flush 1. Notice it shows up here as well, because a constraint is always between two parts. and here is flush 2. Now if I right click and delete one of these, it deletes it from the other one as well. Now that's no longer constrained like that. So remember that you can always go back and delete constraints, and you can go back and edit constraints as well. But to find them, you expand these tabs here, or you could expand the relationship, which actually shows you every single constraint we make, and you'll see more and more added as I do this. So now that this is constrained this way, I can actually go back to like free rotate and rotate this around. But because there are constraints, as soon as I get out of this and kind of move, it's going to snap back to those constraints. So yes, you can free rotate something around, but it will snap back to the constraints that you've forced it to have. The next type of constraint I want to show you is the insert constraint. And the insert constraint is pretty handy. And what I'm going to do is hit C for constrain, hit the insert constraint here, and click this edge or this edge, really doesn't matter. Notice it gives me an edge which is in some plane, and it gives me an arrow. And here the default is an opposed insert, and so if I go here and this edge, notice I get a corresponding circle and a arrow that is that's pointing the other way. And so if I click right here, it will cause those two faces to be mated and the axes to be aligned. And I can hit apply. Basically, a mate constraint is two different constraints in one. It's actually a constraint for mating two axes and mating two faces. And let me show you how you could do that same insert but do it in two constraints instead of one. So I'm going to copy this and paste it. So I get another copy of this because I actually need 4. Might as well do all 4. I'm going to do this using constraints, the mate constraints. And I'm going to constrain this piece to this hole using two constraints instead of the single insert constraint. The first is the mate constraint of axes. I need to choose basically a cylindrical surface. So it's either here or I could go like inside. Notice I get an entire axis. A common mistake is that people click here and just get the center point. So you need to click on the cylindrical face here or the inner cylindrical face here to get that entire axis. Now I'm going to zoom in and do the same thing for an axis here. It can either be this cylindrical face or this cylindrical face. They share the same axis. So if I click that and hit apply, notice the two axes are constrained. But the face here is not mated to this face here. And so if I hit C for constrain and I click here and here, now those two planes are mated. And basically I get the same thing that the insert constraint gave me, but it took me 2 steps to do that. So in a situation like this, it makes sense to just use the insert constraint. It will save you time. Common mistakes, though, when people do the double constraint like this, or anytime they're trying to mate two axes, is they'll go constrain, and instead of making sure they get the cylindrical edge and get the entire axis, they get a point like this. Then they go here, and they might choose the entire axis here. Everything looks good, but if I start grabbing the part, notice how it kind of rotates, because it's basically that dot is constrained to this axis. So you can take a center point and constrain it to an axis, but we do not want that. And so that is a bad constraint. We need to click here, find that constraint, and right click and delete it. Again, the proper way would be to choose the entire axis and then choose the entire axis here. Notice, what if I chose the axis here but then chose this center point? Might look good initially, but notice how this again rotates. So again, you need to be careful that you choose two axes when you're trying to get something axially aligned. But again, the preferred method would be insert, click here, and then click this edge, apply. And then we'll do this to the third one, constrain, insert, click this and find it. Be careful to click the right spot. If you click the wrong spot like this, again, we can just go back and edit it. So if you can hit apply and you didn't like that, you can go here and, well, find that constraint. I guess it's here, and either modify or delete it, and edit it or delete it. I'm just going to delete it and then go again. So constrain, insert this with this. Notice you can do an aligned where the two vectors are aligned with each other. We don't want that. We want them opposed. Then we hit apply. So I have these four pieces in, and now they're locked in place, and that will define the spacing between the two plates, because all I really need to do is go constrain. I can do an insert constraint between here and here, or just a mate between this face and this face. So basically we're just going to work through and start adding additional parts. I'm going to put a bearing. These bearings are a little tricky because the flanges have fillets on them, and it's important you select the right surface. I'm going to insert them just using the insert constraint. Do not click here. You need to either click this edge or this edge here. Anything, because this is the surface right here that will rest on the outside of the plate. So if I click there, you can see I get a surface and an arrow. So now I can go here and hit apply. And I can keep doing that for each of these four bearings. It's a little tricky on the plates because they are transparent, so you want to make sure you're selecting the appropriate edge. But in short, the flanges of these ball bearings are all going to be on the outside of the plate. The flanges prevent the bearing from sliding all the way through the hole. If they didn't have the flanges, there's nothing in this particular part to keep the bearing from just sliding through the hole. And so the flanges keep that from happening. So now we have that placed in. I'm going to keep going. I know that these gears, this part of the gear that sticks out is going to be resting on the inner race of the bearing. That's the inner part of the ball bearing that spins independently from the outer part. And this face is called the inner race, and this is the outer race. And so I'm just going to click here on the bearing, hit apply, and then we will do it for the next one. Looks like I'm getting a save reminder. Again, that's always a good idea to save your part or save your work before you're completely done with it. So I have those in place. Now what I'm going to do is put the axles, the top and the bottom axle are actually the same. So I'm going to make a copy here. And I'm going to do a mate constraint. Now notice, since this is flat, I don't want to select this edge. I could select that rounded part of the vertice, or I could go in here and select this. And I can select this. Now I really don't want to do an insert right now because I will later define how far out and in this sticks in. And that will be defined by the spacers and what goes on it. You can actually do something like this. I'll show you. I'm going to delete this flush constraint, but I could make this flush with this and then have some offset. Notice I could have like a 1/2 inch offset or something. I don't know what that offset is right now, and so I'm going to just cancel this out, but that's how you can actually enter in offsets in your constraints. So they're not flush, they're 1/2 inch offset from one another. So I'm going to do the same thing with the other axle. And go there. I'm going to stop this video here, and in the next video I will have the remaining parts in, and I'm going to show you a couple of additional constraints that we will need to add, and the bolted connections that you need to add as well.